Hi and welcome to today's class. Today is the 14th of May and this is class number 88. So today we're going to keep going with distance, speed and time, and we're going to focus in on what are called distance time graphs. So we are looking at graphing what we've done earlier in the week. So a distance time graph, or known as a travel graph, is a special type of line graph used to describe a journey. The vertical, or the y-axis, represents the distance from a certain point, while the horizontal, or the x-axis, represents time. So here is an example. We can see that the time here is given in hours and the distance here is in kilometers. So it's showing us a return journey. So let's look at this journey in a little bit more detail. So this is a distance time graph of a cyclist who set out from town A. Note that both A and F represent the town. Now, that might seem a bit mad, but think about this. The y-axis, that distance, is the distance from the town. So the cyclist travels away from the town and then back to the town. So when he gets back and he touches that x-axis, that horizontal axis, he's back where he started. So note some things. From A to B, he cycled 20 kilometers in 1 hour. So here we have, and I'm going to try highlight as we go, along the time we have 1 hour and they traveled 20 kilometers. So therefore, you could then tell me really quickly his speed was 20 kilometers per hour. Here at B, he stopped for half an hour. So that's this section here where he was stopped. So a flat line is saying that he hasn't, in that time, changed his distance. So if you don't change your distance, you haven't moved. You're still the same distance away. So he must be stopped. So flat line on the graphs tell us that he's stopped. Oh, I've jumped ahead. At C, he took a lift on a lorry and he traveled to D at a distance of 40 kilometers. How we've worked that out, let me get my pen, is there's our 40 kilometers between 20 and 60, and he did that in half an hour. So there's halfway between 1 and 2. So that's 1.5 hours and 2 hours. So if you did 40 kilometers in half an hour, that would be 80 kilometers in an hour. So he was traveling at 80 kilometers an hour. And that's interesting. And you might have spotted something by now about this line graph that we talk about a lot. But I will talk about that in a sec. But just if you've seen anything interesting, just hold it. So he then rested for half an hour. So there's our flat piece again. He rested. That's the portion given by D to E. And finally, he took the train back to town. He had originally left and completed the 60-kilometer journey in half an hour. So 60 kilometers in half an hour. So that's 120 kilometers in an hour. So he was traveling 120 kilometers an hour. So we have this lovely graph that tells us a lot about a journey without having to give us any written information. Everything is displayed on the graph. Just be aware of some things. A change in steepness represents a change in speed. The steeper the line, the faster the speed. The flatter the line, the slower the speed. A horizontal line indicates a person or an object has stopped. And what we're talking about here is slope. So maybe you caught that. So if I ask you to calculate the slope of the line AB, that would be rise 20 over my run, which is 1. So my slope would be 20. But that's also my speed. So we get this lovely idea that speed on a graph is given by slope. Now, you're like, oh, mind blown. So this has no slope. It's flat, so it has no speed. Here we have rise, so 20 to 60, rise over run, which is a half. So you do 40 divided by a half, now be careful, which is 80. So that's 80 kilometers per hour. And then we have this idea here of this negative line. So we've had two positive lines and a negative line. And I'm not really sure what you see in science, but that has got to do with the idea that although speed is just a number, it has a kind of a companion that's called velocity. And velocity is a vector, which just means that the plus or the minus, if I put it in front of a vector, tells us the direction. So the fact that the plus slope is going to, or sorry, away from town A, then the negative slope is coming back to town A. So that positive or negative is actually telling us a direction. So I don't know how much of that you see. I think you use the word velocity anyway in science. Velocity and speed are pretty similar. We don't have to worry too much about the differences. But if you're wondering about why is one slope positive and one slope negative, positive is going one direction, negative is then coming back. It's going the opposite direction. And we have that idea in maths already. If you have a number line and I say add, you move to the right. If I say subtract, you move to the left. So we already have this idea of plus going one way, minus going another, but we may not talk about it explicitly.